All right, guys. So today we are going to cover problem solving and data analysis. All right, and so today we are going to talk about problem solving and data analysis. The topics that the College Board generally includes in this kind of overarching umbrella is going to be all the
Да-да-да, Рэйчел придет туда.
Thanks. So what the College Board generally includes in this kind of topic is proportions, so percentages, rates, ratios, and proportions, and then unit conversions, as well as center spread and shape of distributions. They also might ask about data representation, scatter plots, linear and exponential growth, probability and frequency, data inferences, and evaluating statistical claims. Um, These are quite broad, but if you remember from the PowerPoint yesterday, problem solving and data analysis, usually there's only about 5 to 7 questions covering this type of material. So it's not necessarily the like content area you have to spend the most amount of time studying for the exam. Today, we're just going to go ahead and cover the topics highlighted in bold here. So everything under proportion, and then center spread and shape of distributions. This is really going to be like the foundational stats and data analysis knowledge that you need to have. Of course, if you guys do study outside of this, it would be good just to take a look at some of this other um, like topics, especially if you haven't taken a stats class. But that being said, we're going to go ahead and move on to the practice problems. If you guys have questions, just feel free to pop them in the chat or raise your hand. And then, like yesterday, for every problem, if you guys are doing it on your own and you come up with an answer, also feel free to drop that in the chat. So we're going to start off easy with some percentages. And then just a refresher, again, this should be pretty familiar to you guys. Percentages is something out of 100. So it's going to be the part over a whole times 100, or if you're going from a percent to just like a coefficient, it's going to be divided by 100. And then it's going to be really helpful if you remember how to use complementary percents to solve questions. So the example here is that if we take 20% away, what percent is left? 80%. The College Board isn't going to ask you any questions that are just this right here. If we take 20% away, what percent is left? This is usually going to be part of a like larger question that you have to solve. Um, yeah. So keeping going. And then translating percentage in word problems. We know that the SAT writers love word problems. So it's really important to understand how these topics will show up in those types of questions. Um, so you'll see percentages used in word problems, obviously. And there's pretty easy ways to know how this translates to arithmetic if you're writing it out. So usually when they say what means X, or it's the unknown quantity. And then usually when you see is, it means equal to, of means multiplied by, and then percent means a number divided by 100. So using this example, 36 is what percent of 60? So we see the what, so it's the X right here in the question. The is equals to, and then percent of we know means divided by, so we divide this unknown quantity by 100 and multiply it by 60 to get 36. All right, not seeing any questions yet. That sounds good. All right, we're going to move on to our first practice problem of the day. So if a student answered 86 problems correctly, which was 81.9% of the total number of problems on the test, how many problems did the student answer incorrectly? So taking this, we know that 86 is All right, so they're asking us how many problems did the student answer incorrectly? So, using some problem solving strategies just before we even start the math, if we know that 86 is 81.9% of the total number of problems, we know that whatever number that was incorrect has to be less than 86. So using that, we know that the answer cannot be C because if they got 86 problems incorrect and then 86 problems correct, this percentage would actually be 50. So we know it's not C, and then we know it's not D because D is also greater than 86. And so if they did answer 105 problems incorrectly, this percentage here would be less than 50. So we know it's not D. So we either know it's A or B, which narrows it down pretty well. Let's see what people are saying in the chat. Okay, people are saying B in the chat. All right, let's do this out. So 86 is going to be, oh, all right, sorry. Okay, so 86 is some quantity. All right, so we're going to have an X because we're looking for how many problems that were incorrect. And then we know 86 is going to be 81.9% of the total problems. So, all right, let's write this out. It's going to be, mm, it's not, okay. So, if it's, all right, people in the chat are saying it's, you have a couple answers for B. All right. And so using that problem solving strategies, working backwards or back solving. So if we think that it's B, so 100, oh, sorry. Huh, I'm not good at this whole Zoom thing. Okay. So equals, all right. So 0.819 and then 86 is going to be divided by 0.819. So get out my calculator to do that. Remember, guys, you guys are going to have Desmos on the whole test, so that's going to make it pretty easy for you guys. Okay, so this is how we're going to do it out algebraically. 86 is 0.819% of some total number of questions. So when you do this math, this is going to be 105 as the total number of questions on the test. But remember, that's not what they're asking us. They're asking us how many the student answered incorrectly. So actually, to get the correct answer, you're going to want to make sure you remember to subtract 86 from this, which is going to get you 19, which will make B correctly. So B correct. So if you said B in the chat, you guys are right. Again, remember not to get switched up. They do include 105 as an answer in D, but you have to make sure you're giving them the answer that they are asking for in the question. You guys can also back solve if you if you narrow down the answers and you're not exactly sure how to do this out algebraically. So doing, you could add 86 plus 19 is going to be equal to gonna be 105, and then you can multiply this by the 0.819 and make sure it is equal to 86, and then you can do the same thing with A if that was the answer you started with. I don't see any questions in the chat, so I'm going to go ahead and move on. Again, percentages are going to be pretty easy for you guys. So we're going to move on to rates, ratios, proportions, and unit conversions. Just building on your knowledge of percentages. Again, just some important refreshers that a ratio is a comparison of two quantities. So if you have A and B, it can either be written like this or as this is a ratio and it is a fraction. And then a proportion is an equality of two ratios. So that's when you have an equal sign. And then we usually use these to to solve for unknown quantities. So one of the four terms in the proportion is going to be unknown, and we'll solve for that. And then a rate is just the quotient of a ratio where the quantities have two different units. So this is going to be things like miles per hour, um, meters per square inch, things like that. Not seeing any questions in the chat. That's weird. Oh my gosh, sorry. Okay. And then an artist advertises an enlarged model of a scorpion fly. If the scale of the model to the original is 36 to 1, and the model has an enlarged width of 1,170 millimeters, assuming these measurements are accurate, yes, I can. Yes. Do you have any specific questions about this slide? Okay. Okay. So, assuming these measurements are accurate, how wide was the original scorpion fly in millimeters? So, 36 to 1. Remember, when you're doing a proportion, when you're writing a proportion out, this first number is going to be the numerator. So, it's going to be 36. And then the second one is going to be the bottom to 1. And then it helps if you know that our that models are generally bigger, but they also say that this is an enlarged model of a scorpion fly. So the number that we're going to get, we're going to make sure it is smaller than this 1,170 millimeters. So we put this here. And then how wide was the original scorpion fly in millimeters? So it is 36 to 1, so 1,170. No, okay, so it would be flipped. Shift X, right? Because for every 1 millimeter of the original scorpion fly, the model is actually 36 millimeters. So for some amount of this, it's going to be 1,170, and then you just cross multiply to solve. So 1,170 is going to be equal to 36x, and then you're going to divide both sides by 36. We get x equals in the chat 32.5. Yes, that should be the correct answer. I'll just go ahead and do that on my calculator over here. Yep, 32.5. And then make sure you include that unit on there because they are asking for it in millimeters. All right. We are looking good, guys. Gonna go ahead and move on to the next practice problem. So, a watt hour is a unit of electrical energy equivalent to a power consumption of 1 watt for 1 hour. About how much energy in watt hours is required to keep a 6-watt light bulb lit for 4,800 hours. So, all right. So it's 1 watt per hour. And then they tell us that it's a 6-watt light bulb. So what that means is that for every hour, this light bulb is going to need 6 watts of electricity to power it. And then they're telling us that this light bulb is going to be lit for 4,800 hours. So if it's 6 watts per 1 hour is equal to, um, so it is going to be some amount of watts for 4,800 hours is the purport, is the ratio. And we say ratio because these two units of measurement are different. So it's going to be x is equal to 6 times 4,800. So it's not going to be A or B because those are too small. And then we go ahead and do this on your calculator. So 6 times 4,800. So the answer would be D, and I'll see what you guys put in the chat. B. Yes. So, yeah. So B would be if you put this 4,800. But remember, in a ratio, we want to keep it so that the units with the same measurement are equated to each other. So, because this is 1 hour, we have to keep it equal to the 4,800 hours. So that would mean this would be in the denominator. You would get 800 if you put the hour in the numerator. So that would be how you would make that mistake. So just make sure in these ratios that the same units with the same measurement are equated to each other. So they're both in the denominator and they're both in the numerator.
What if you was to flip both of the fractions?
If you were to flip both of them, so it would be 1/6 is equal to 4,800 over x. And it would just be the same algebraically because you would still cross multiply. So it would still be x is equal to 6 times 4,800. And then you'd get x equals 28,800. Yep, so it doesn't matter if you flip it as long as you make sure that the terms with the same units are equal to each other. So they're both either in the denominator or the numerator. All right. Take a look. See something in the chat. Perfect. Okay. All right. So another practice problem for you guys. This one with a visual they give you. So which of the following cities had the largest population density in 2010? And its population density is defined by people per square mile. So they give us 4 cities and then essentially, so to write this out as proportions, I'm going to use Boston as an example. So it would be one, their population density is per square mile. So you have to make sure that the mile is 1 in one of the proportions. And then they're saying the area is 48.43 miles, square miles. So, like I said in the last problem, you're going to want to make sure that the terms of the same unit are equated to each other. So we'll put both the mile measurements in the denominators, and then for the numerators, you're going to do the total population, and then this one is going to be the term that we're trying to find. And then what you're going to do is you're going to cross multiply. So it would be 48.43. X is equal to 4514. No, sorry, it's a little bit squished on there. And then you're just going to divide this by the 48.43 to get the population density per square mile. And this problem is asking you to do it for all of these cities. I see some chat activity, so let's see what people are saying. I see a couple of A's and B's, so we either think it's Boston or Chicago. I'm going to do that real quick on my calculator. Chat open. So I hear people saying it's A for Boston. So let's do 645,149 divided by 48.43. So for Boston, I'm going to write this down. It will be 13.4. And then for Chicago, 2695, 59 each, divided by 227.3. All right. So, okay, so this is going to be let me just make sure. Okay, so I did Boston wrong. Boston is going to be 645.49 divided by 48.43. Okay, yep. So Boston is going to be 13,321.2. All right, so we know it can't be B because Boston is greater than Chicago. I'll do out the other two just to make sure. So 3, 6 for Miami, 470 divided by 35. All right, and it can't be Miami because Miami is around 10,000. And then Philadelphia, 15, 17, 550 divided by 5.0 equal to 11,000 ish. So, yes, to those who said A in the chat, you guys are going to be correct. And again, you just do that by, you can set up these proportions, but you can also just divide the total population by the total area. All right. So getting on to center, spread, and shape of distributions. Again, these are things that all should be pretty familiar to you guys. So just as a refresher and a little bit more about with some stats vocabulary, center, spread, and shape are known as summary statistics, or we just call them statistics. And they're used to describe data sets that we see. So the center describes the typical value of a data set. And there are 3 measures of center that the SAT wants you to know, which include mean, median, and mode. Like I said, these all should be familiar to you guys from pre-algebra and algebra. And then spread is going to describe the variation of the data. And the SAT uses 2 measures of spread, which include range, which should be familiar to you guys, and then standard deviation, which might not be quite as familiar. So standard deviation is the typical distance from the mean, so the spread from the mean. And then larger and important to note about standard deviations is that larger standard deviations indicate a greater spread in the data. So that would look like something like this would have a large standard deviation because there is a large distance between these data points and the mean. And then something like this would have a small standard deviation because the distance between these 2 points is going to be pretty close to the mean. And another thing that I make sure to tell people is that you won't be asked to calculate standard deviation. It's a pretty long and tedious algebraic calculation. So really, they are just going to ask you about standard deviation to make sure you understand the topic, understand how it's applied, and understand what it looks like when they give you data to look at. So things like graphs or data sets. All right. All right. So feel free to answer these in the chat as I'm going along. But just as a refresher on how to find mean, median, mode, and range. So range is going to be the greatest value minus the least value of the data set. The mode is going to be the most frequent value of the data set. Yes, mode is the most common value seen. And then median is, you guys probably learned it calling it the middle. Too many D's in that. So it's the middle number in the data set. And I know I learned it this way, and I'm sure you guys did too, where you look at a data set like this, and you do just the old cross out method where you're like, okay, these two are on the end, and then these two are on the end, and then, oh, three is left, so this must be the median. That is a way that you can do it. There's also a way to calculate it algebraically. So it's going to be n plus 1 divided by 2. And then n, whenever you see n in a stats and data analysis question, n is just going to be the number of data points. And then mean is the average. And it's going to be the sum of all values divided by n, or the number of data points. All right. Again, these all should be pretty familiar to you guys from algebra and pre-algebra, but we're going to do some practice problems just as a refresher and get you guys in the swing of things. All right, but looking at these alone are going to be pretty easy to calculate because you learn them in like pre-algebra, algebra a long time ago. So you're not just going to see questions that ask you about, so you're not going to see questions that just ask you to really find the mean, the median, or the mode and range. Usually they're going to ask you to use your understanding of what those, of how you calculate those and what those mean for a data set to get to a different answer that they're looking for. So this is an example. They're asking us to solve for a missing data value. And in the question, they tell us that the mean of these 5 numbers is 30. And then they're asking for the value of x. So to solve this, they're asking that you understand how to calculate the mean, but also how to work backwards. So looking back at what we just talked about with how to calculate mean is going to be the sum of all of the data values over the total, over the number of actual data points. So this data set has 5 points. So in the denominator, we're going to put 5, and then in the numerator, it's going to be the sum of these values that we have and x. Don't forget to include the x in that because you are solving for it. And then they also tell us that the mean is going to be 30. So we know that whatever this sum is divided by 5 has to be equal to 30. So, and then once we have this set up, you just solve. So we're going to add these four terms. So it's going to be 140 over 5 is equal to 30. Multiply both sides by 5 to get it out of the denominator. To get x plus 140 is going to be equal to 150. And then you subtract 140 from both sides to get x equals 10. And then you can double check that by adding these all up again and adding 10, and then dividing by 5 and making sure you get 30. Let's see what people in the chat are saying. Yes. All right. So I see people who put their answer in the chat said 10. So you guys are all going to be correct, which is awesome. And for the sake of time, we will go ahead and move on. All right. So this is a word problem using these topics that we've been talking about. So they give you the data set and they give you it in this table format. And again, the question is just asking us to find x. But then they tell us that the table above shows the number of points that Marco scored in the last 6 basketball games he played. Marco doesn't remember how many points he scored in game 2, but his coach tells him he averaged 10 points per game. So we want to find this. All right, and so the average, remember, is the sum of all of the data values over the total number of data points. So it's going to look pretty similar to this last question that we did, where if there are 6 values that 6 data points we're using, we're going to put 6 in the denominator. The question tells us that the average is going to be 10 points per game. So that's going to be to the right of the equal sign. And then we're going to put the sum of all the points scored in the numerator over here. So it's going to be 11, 13, 7, 9, and 12. And then we can solve for that. So it's going to be x plus, these make 20, these make 20 plus 12. So it's going to be x plus 52 over 6 is equal to 10. We're going to multiply both sides by 6 to get that out of the numerator, or out of the denominator. X x plus 52 is going to be equal to 60. And we just subtract 52 from both sides of the equation to get x equals 8. And again, if you wanted to double check, you just plug this value back in for x, divide it by 6, and make sure that it's 10. I see some activity in the chat. Let's check it out. Yes, so everybody in the chat is saying 8. Good job, guys. You guys are all correct. I'm not seeing any questions. So I'm going to go ahead and clear this and move on. All right, so another word problem. And again, this is a question where they give us a graphic representation of the data. So this dot plot depicts the annual snowfall in centimeters in Syracuse, New York during the 1990s, rounded to the nearest 10 centimeters. Which of the following statements offers the best explanation of the mean and median of this distribution? All right, so this question is asking you to apply these concepts of mean and median to this graphic representation of data. So using that, all right, I'm just gonna look. So the median, just looking at this data, it looks pretty symmetrical to me. So the median is going to be this probably around 130. And then the mean right, the mean is probably going to be around. Also, I'm just thinking the mean may also be close to 130. But let's look at the answer choices they give us and see if anything off the bat looks like something we can eliminate. So, all right, so D says that there's not enough information to compare the median and mean. We can go ahead and cross this one out because they do give us enough information. They give us the data set here. If they had just given us this word problem and then they hadn't included this graph, then there wouldn't be enough information to draw a comparison. But they did give us this graph, so we know that it can't be D. And then A says that the median snowfall is less than the mean snowfall because there are more years with annual snowfalls greater than 130 centimeters than there are with annual snowfalls less than 130 centimeters. So greater than 130 and less. So looking at this, it says that there should be more data points on this side of 130 than there are on this side, which isn't true because to each side of 130, there are going to be 4 data points. So we know that it can't be A. And then this B says the median snowfall is greater than the mean because there are more years with annual snowfall less than 130 centimeters than there are years with annual snowfalls greater than 130 centimeters. So essentially, they're just flipping what they said from B or from A and putting it in B. And so we know that B is also not true because the years of snowfall with snowfall greater than 130 is the same as the years with snowfall of less than 130 centimeters. So it can't be B. So we know that the answer is C by process of elimination, but also if you look at it, it says that the median snowfall is approximately equal to the mean snowfall because the data distribution is symmetrical. And we can verify this by looking at the graph. If this is the center point, looking to the left and the right of it, they look the same. So the distribution is symmetrical. So we know that C is correct. And also looking at kind of just eyeballing the median and the mean before we even took a look at those question answers. So what I mean by symmetrical is that when you look at the median of the data, so if we were to calculate the median, because this is easy, I'll just use the crossout method. So if we're going to calculate the median, we can eliminate these 2 points and we can eliminate these, and we can go ahead and eliminate these and then eliminate these. So the median is going to be 130. And then once we know that this is the exact center of the data set, you can kind of just look and visually see the symmetry. So we see that one, so this is 1, 2, 3, 3 of these tick marks from this median. There are going to be 2 data points, 1, 2, 3. So that's the same on both sides. We go fourth and there's only 1. We go fourth and there's 1. So that's the same. And then we go 2 more and there's another data point and 2 more and then there's another data point. Okay. Did that answer your question about what I mean by symmetrical? Okay, perfect. Yes. So the answer is going to be C. Again, yes. Okay, so we will keep going and look at another problem. All right. So again, another representation that they give you. This time it's in a graph instead of a line plot. So they say that this graph gives the average temperatures in degrees Fahrenheit for city A and city B over the same 7 days in March. If M of A and S of A are the median and standard deviation of the average temperatures for city A, and then they say that M of B and S of B are the median and standard deviation of the average temperatures in city B. And then they ask which of the following is true. So, and then they give us 4 options in the multiple choice. So answer A says that the median of city A is greater than the median of city B, and that the standard deviation of city A is greater than the standard deviation of city B. Answer choice B is the same for the median. It says that city A has a greater median than city B, but that city B actually has a greater standard deviation than city A. C says that the median of city A is less than the median of city B, and that the standard deviation of A is greater than the standard deviation of B. And then D says that the median and standard deviations of city B are greater than the median and standard deviation of city A. So I'm seeing some answers in the chat. People are saying C. All right, I'll make a note of that. Okay, so people think that it is C. All right, so looking at this, the first thing that you're going to want to do is calculate or estimate the median. So if median is the center, so 1, 2, 3, 4, 5, 6, so we go 1, 2, 3-ish. So the median is going to be around this point in the graph, around day 4. And so looking at this, city A is this solid line and city B is this dashed line. So we see that this solid line for city A, around where the median should be, is lower on the graph than the line for city B. So we can say that the median for city A is going to be less than the median for city B. And then we can use that to eliminate some answer choices. So we can eliminate B and A because they say that the median for city A should be greater than B, which we know is not true. And then looking at standard deviation is just going to be the distance from, like I said, it's distance from the mean. And so looking at this graph, you just have to tell which one, you just have to decide which one has greater distance from the mean. And so because looking at this, we see that city A it has a greater change in the data than city B. So we can say that the standard deviation of city A is actually going to be greater than the standard deviation of city B, which will make C correct. And so everybody who put C in the chat, good job. You guys are all correct. All right, and if there are no questions about that, I'm going to keep on moving. All right, any questions about what we talked about up until this point? I don't see any hands or any questions. We're going to do a couple of practice problems before we hop off for the day. All right, if you guys do have any questions, feel free to put them in the chat. All right. So the regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? So, again, looking at percentages, and this is going to be like similar to a real world application of percentages. So the original price is 11.7, and we know that the sale price is going to be 80% of that. So if we calculate that, 11.7 times 0.8, we get that the sale price is going to be $9.36. And we also know, and then they say that the sale price is 30% greater than the store's cost for the shirt. So whenever it says 30% greater or you're increasing in a percentage, essentially what it's going to be is it's going to be 1 or 100% plus whatever percentage you're adding. So in this case, it's 30%, or if you convert that, it's going to be 0.3. So we're going to multiply, and then I'll use a different variable for the stores cost. So we're going to multiply whatever the stores cost is, it's going to be multiplied by this 130% to get this 9.36. I see some people in the chat. All right, here's 7.15. Yeah, let's do this out. And then you just solve here. So you divide both sides by 1.3. Yes, so I am, when I do it on my calculator, I am getting 7.2. So you guys are all in the area of the answer. It's just gonna be, so the storage cost is going to be 7. And remember to write it with both decimal places because they are asking for the cost in dollars. Okay. Yes. 17. Okay, yes, and just make sure you multiply instead of, or make sure you divide instead of multiply. Yes, but again, these percentage questions should be pretty fast and easy for you guys. Go ahead and we have a couple more minutes. Okay, so another question. This one is a multiple choice. A candle is made out of 17 ounces of wax. When the candle is burning, the amount of wax in the candle decreases by 1 ounce every 4 hours. If 6 ounces of wax remain in this candle, for how many hours has it been burning? So this question is asking us to make a ratio. So for every 1 ounce, 4 hours, this is going to be the rate of the wax burning or the rate of the wax decreasing. And then they say that 6 ounces of wax remain. So you put 6 because remember in a ratio, you keep the values with the same unit in the same part of the ratio. So either both of them in the denominator or both of them in the numerator. In this case, I'm putting the ounces in the numerator and the hours in the denominator. Hours. Okay, so this is not going to give us the correct answer. Okay, actually, so for this question, instead of using the 6, what we're actually going to do is we're going to subtract this 6 from the 11 from the 17.
Can't you just do 11 times 4?
Yeah, you can also do, yes, you can do 11 times 4. But this is just, I just want to make sure I go ahead and show you guys how to do it with a ratio. So yes, it would be 11 ounces left over X hours. And then when you write this out as an equation, it would be X equals 11 times 4, which would be equal to 44, which would make the answer D. Yes. So yeah, make sure that you are reading the question and um, getting that answer correct, because if you use the 6 instead of the 11, it's going to give you C as the answer instead, which would not be right. Or did you get 11? So they say that 6 ounces of wax remained. And so if you know that there are 6 ounces left, um, we know that 11 ounces of the wax burned because it's 17 minus 6. So over however many hours it's been burning, it lost 11. And we need to use the 11 instead of the 6 because this is the rate of how many ounces burned, not how many ounces are left over after those 4 hours. Okay. We have time for one or two more. Okay. So a sample of oak has a density of 807, kilograms per cubic meter. The sample is in the shape of a cube where each edge has a length of zero point 0.9 meters. To the nearest whole number, what is the mass in kilograms of this sample? So, okay, let's do this out. So he says 807 kilograms of cubic meters, which you write as meters cubed. And then the sample is in the shape of a cube where each edge has the length of zero point 0.9 meters. To the nearest whole number, what is the mass in kilograms of this sample? So they give us this ratio in kilograms per cubic meter. So and the meters cubed is going to be calculated in by the length of the side times 3. So length times 3. And so if this measurement instead of being 0.9 was 1, we could say that the mass would be 807 kilograms. But because this is 0.9, it's going to be less than 1. We can know that the mass is going to be less than 807, which will help us eliminate some of these answers because C is greater than 807, as is D. All right, so that leaves us A and B. And then so if it's, again, a ratio problem over 1 meter cubed, we're looking for X over 0.9. And then you just multiply this out. It'll be X 0.9 times 807, which should be 726. Yes, 726. When you do it on the calculator, there's a decimal. So you just round to the nearest whole number. All right. Let's see. Any questions in the chat? Yes, again, make sure you are setting up this ratio correctly and multiplying 807 and 0.9, not dividing. Yeah. All right. All right. We'll see if we have enough time. This is going to take a couple of minutes. Okay. All right. I don't think we have enough time to do this out. Yeah, this is one that would take a little bit longer, and we only have a couple minutes left in the session. So I'm gonna end here. If you guys want to take a look at this and try to solve it on your own, feel free. I also know that this is a format of practice problems that that the College Board really likes, and so there are quite a few available online to you guys. But since we are at the end of our session, I'm going to stop sharing my screen. Does anybody have any questions for me before we end for the day? Thank you guys for showing up. Next week, tomorrow, we are going to cover geometry. So that'll be triangles, circles, and the unit circle, I believe. and some of the trig involved in the geometry. But if you guys don't have any questions, feel free to leave and enjoy the rest of your day. If I don't see you tomorrow, enjoy the rest of your break. Tomorrow our meeting will be from 5 to 6.
Will we be doing arithmetic tomorrow?
Yes. Yeah, there's calculations involved in the geometry.
All right. Goodbye.
Bye.